I grew up really hardcore science fiction reader. Asimov, Timeline, those kinds of things. Like many things, you sort of end up being lucky in the right place at the right time. I'm not so sure I'm convinced that AI helps us build a better rocket engine right now. I've been to NASA almost 34 years, and in 34 years, every year we've always been 20 years away from going to Mars.
Hello, this is Der Heilige Stuhl, the podcast with Alex and Jörn. Today in English with a very special guest today again. With us is James Lewis, Associate Chief of Structural Engineering. Man, I got that out correctly. I actually practiced that. Barbecue lover and overall NASA space lover, I think. So great that you're here. How do you feel today, James?
I feel good. I appreciate the opportunity to come here. I'm impressed that you got my title out because I still uh, trip across it on my own because it's a relatively new assignment for me. But yes, I am the acting associate chief for the structural engineering division at NASA Johnson Space Center in Houston, Texas.
All right. And with us is Alex as well. I hope you're okay as well, Alex.
Yeah, I'm totally fine.
Great. So I'll start with the first question. And to lead into that question, I give you my understanding of what it is you actually do. My understanding would be you're the guy who makes sure that stuff doesn't break in space, at least not otherwise. Is that correct?
That's probably a good description of my organization. Organizationally, we have north of 100 folks these days. And we do a primary function is to make sure that in the area of in five disciplines that structures, mechanisms, thermal, um, material sciences, loads and dynamics, that those attributes in all of NASA's programs for the vehicles that fly people into space, we keep those disciplines sound so we can keep those people safe. That's what we do.
Mm-hmm. Okay. So my follow-up question to this would be, is there any specific engineering rule that applies on Earth that doesn't apply in space? Where you say, yeah, we have to actually treat this completely differently than we would on Earth. And if there are many, what's your most surprising rule?
Probably is the biggest and most common thing that people think about and talk about is the lack of gravity. The gravity affects everything that we do on Earth. Every place you go, everything that's built, everything that flies or rolls or does whatever is influenced by gravity. But when you get far enough off the Earth's surface, we get into what we call typically microgravity or zero gravity, depending on which altitude you're at. But gravity is a huge component of life on the Earth. But as you move into space and you don't have gravity, everything just works differently.
And is that, I would say, a negative issue where you say gravity presents you with many great problems? Or is it a positive issue where you say, oh, maybe we don't have that much friction or things last longer? So, or is it both?
It's really kind of both. It probably depends on what you're talking about. When you think about the systems that we build to get people into space, whether it's launching or circling in orbit like the space station is, those things you have to design them to get there, which is quite a ride in most cases, and they have to be able to survive that in space. But the people is very hard because their bodies themselves don't live very well in the lack of gravity because we are designed to be in a gravity environment. However, there are facets of what we do in space, things like science, where we're doing sort of maybe a biological or material science that would specifically we're doing them in space because the lack of gravity is a benefit. So you end up seeing both, depending on what you're talking about. So, sorry. Yeah.
It's no problem. We can introduce your cat as well. Basically, as far as I understand, cat videos are absolutely great for YouTube content. So,
okay.
Well, so there's another 5,000 views.
I'm sure she will be back.
Yes.
As
Well,
long as she doesn't start an OnlyFans, everything's all right.
yeah. Great. Don't make this podcast basically PG-18, Alex. um,
So, so
so,
hopefully that last answer was sort of what you were pulling on.
mhm.
Gravity is obviously a big human life thing. When you think about there are other environments associated with space. Then when you get in a craft and you move into what we just call lower orbit, specifically, you have to bring your own oxygen, which we have on Earth. So you have an environment that you're missing in space. And so, depending on if you can bring enough oxygen with you, or whether you can regeneratively resupply that some way, and so we also losing protection of from the radiation that comes from the sun. So as you get further into space, there are other things that become a relatively major player, and things like lack of oxygen and increased radiation are very hard on systems, including the human system.
And how hard is it for James Lewis to actually watch space movies where they absolutely disregard all this stuff? Basically, can you even watch like The Martian, where you say, dude, you're out in the radiation with absolutely no atmosphere to protect you and you're taking a 3-year walk? Like, or can you shut that off, or is it always a professional in the background when you watch the movie?
No, I don't know that I mean, I grew up really hardcore science fiction reader, Asimov, Heinlein, those kinds of things. And so you end up sort of, I could disconnect myself, so to speak, from, I can enjoy a movie just like normal people that are not space educated most of the time. I think there are times where something does present itself as being accurate. Well, when those cases, then they're not accurate. That probably stands out more to me. They're sort of in the vein of Armageddon flying shuttles like F-16,
Yes,
right? And so there
I
are
love.
certain things that do tend to stand out as, yeah, you can't do that.
Yes.
So although
Yeah.
having read the book and been a fan of the movie The Martian, and knowing that NASA, our head scientist Dr. James Green was involved, they did do a pretty good job in various aspects of realism. So it is comforting that they do display much about the environments and the arduous kinds of things that they have to do. However, there are certain aspects about that like the timing of communication between being on the red planet and being on it sort of seems like it's real time in that movie when it's not. I know they talk about it in the sense of that there's a delay of 20 something minutes or whatever that takes. Um, but at the end of the day, the way the movie progresses, because they can't have a movie that's many, many days
Yeah.
long, they make it look like it's, sort of instantaneous by the way they cut the movie. So
Fun fact, I think Armageddon is the movie most mentioned by anybody who worked with some space-related stuff as the worst possible movie in terms of realism. I had Chris Hadfield absolutely cursing that movie, and basically because they have unlimited fuel, basically weird gravitational effects. So, but
right.
before I go on, I want to let Alex ask some questions because I was yapping for 10 minutes.
Yeah, the questions were very interesting, and it was surprising.
Yeah.
Um,
Yes. Well.
Well, you mentioned science fiction literature, especially Asimov, which I really like. What's your favorite piece of art regarding science fiction, written or movies? Or what was the most important piece of art regarding science fiction for you?
That's a great question, because I read a tremendous amount growing up. I think at some point, like in most folks who you go to college, you have a job, you get married, you have kids, other things tend to take over. But my formative years, I was really a gigantic fan of the Foundation trilogy,
Hmm.
and of Asimov, and so that sort of spoke to me, um, in terms of um, in terms of sort of the science fiction and fantasy genre as a whole. I'm not so much the Tolkien, J.R. Tolkien-y kind of Lord of the Rings, that's fantasy kind of stuff. I like my non-reality be based in reality, I guess, to say it that way. I'd like to think about, it's possible to build a ship. It's possible to have anti-gravity. It's possible to have closed loop life support. It's possible,
Mm.
to have a force field. These are things that are technically, sort of theoretically possible. It's not possible in my mind that you have some fancy ring or some kind of wand that sort of creates things. So my fantasy is grounded in reality. Let's put it that way. So probably the Foundation trilogy was sort of one of the first things that I read where I'm like, okay, this is kind of fun. I can remember probably more college age reading Decology, a 10-set book by who wrote Frank Herbert. No, it wasn't Frank Herbert. That there's a decology. The name will come to me. I am getting old, but and it was just this fun-filled romp of sort of space characters through 10 huge novels. The
Mm.
guy that created L. Ron Hubbard's decology. It's a
Yeah.
10. I don't know if you guys have read that series of 10 books or not. And it is just it's made more just scientific, sci-fi kind of romp through space with these unique characters. And so that's the kind of stuff that I tend to enjoy. It's sort of the probably is the foundation. I can clearly remember in probably about the mid '70s discovering
Mm.
Star Trek episodes from the '60s. And so again, that's the more realistic version of science fiction that I like.
Hmm. Okay, interesting. Yeah, I read Asimov while I was while I was studying. I read all the books. They're awesome. Also, I really like Asimov, so
Yeah.
I can understand this. I relate to this. Another question regarding your time at NASA. You are there about 30 years, more than 30 years now. You're working at NASA, I think, if I get it right regarding your resume.
Yeah, I believe January the 5th will mark my 34th completion of my 34th year.
Which was the or which spacecraft did you like most? Obviously, it would be the space shuttle. Everybody says space shuttle, but was it another spacecraft when you think about it?
Okay, that's a great question. I had to think about that a little bit. So my first exposure to a real spacecraft would have been experimental activity and the program is called X-38, and that's really the
Hmm.
first place. It was a derivative lifting body design that it sort of intended to mimic the lifting body characteristics. If folks have ever seen the '70s TV show The $6 Million Man, there's a scene at the beginning where this vehicle crashes and it hurts the pilot, and they turn him into the sort of cyborg guy with shrink powers. That dinosaur kind of lifting body thing was reinvigorated in the '90s as a way, as a path to develop a way to get crew to and from space station. Primarily, it was intended to be delivered by the shuttle and berthed on station. And they would undock in an emergency or in a normal planned rotation and bring people home. And so that was my first spacecraft that I figured that was in the mid to late '90s. And then again, my role in that was more not vehicle specific. It was more a secondary system. It was the docking system, which is where I end up ultimately have spent the bulk of my career in the world of the docking systems. Now, that is a vehicle, so I kind of had affinity to sort of my first one that I really worked on. I did have activities that I supported shuttle, some flight experiments, and those kinds of things. Um, Later, because docking is on every human spacecraft, essentially, the the activities evolved over time into the Orion vehicle. So probably have to say, sort of, I spent a significant amount of my career supporting the Artemis program's Orion vehicle. Is a it's a kind of a giant sized Apollo capsule, so to speak, intended to deliver folks to the vicinity of the moon. So if I had to pick today, probably would have picked Orion because the most exciting missions for Orion are really
Mm.
just right in front of us at this point.
Yeah, Ryan has been around a little while now. It's the
Yes,
yeah.
it has.
Um,
Yes, it has.
you developed docking systems. You just mentioned spacecraft specificity, and docking systems should not be spacecraft specific. Um, um, did you, the early attempts regarding the docking systems were back in the 70s regarding the American Russian docking systems when the Soyuz and the which capsules were this on the American side started to dock.
Yeah.
And what was your approach? I saw some papers of you, but I think it's quite interesting. Can you tell me what made your docking systems, the docking systems you worked on, so special?
Probably a little bit of a preamble there for me is my very, very first memory of space as a lad
Mm,
would have been the summer of 1975. We heard about ASTP, which is the Apollo-Soyuz test project, which you referenced was a joint activity um, designed in a Cold War period to demonstrate that two powers could meet and be friendly in space. And so it is ironic that I think some number of years later, I ended up working for NASA, having the blessing to work for NASA and actually work in the area of docking because that's actually my very first memory of space. Um, as whatever I was 6 or 7 or 8 year old, whatever I was at the time. Um, so yes, docking actually goes further back than that because if you go back to the earliest, the '60s generation of space, we did rendezvous and dockings. Apollo used a Apollo probe and cone
mm,
mechanism to really think of that as a different kind of system. The system that is based on really a probe in a cone. They're not androgynous, which is the use that word that we use today. So really, you have to be very careful about which sides end up in space needing to rendezvous and dock. You have to be compatible. And so when
mm,
it came about that I came into my career and was worth supporting as a youngster in an organization, we decided that it was a task. I think NASA had funded some stuff in the very late '80s, in the early '90s towards the development of a next generation docking system following Apollo Soyuz, and like I said, in the mid '70s and Apollo Soyuz was a different flavor. It wasn't probe and cone; it was androgynous, meaning that both sides could effectively be identical and they could mate. So if you can imagine,
mm,
kind of a three pedal configuration that 82 halves could meet in space and do their thing. And so Apollo Soyuz was really had come out of the lessons learned. I've read some documentation early in my career. Was one of those kinds of things that said the Apollo experience, the crew, the developers, the mission operators, the fact that one side had to always be active and positive and in a probe situation was not conducive to probably the interoperability that we would need for future
mm,
things. At that point, we didn't have a space station. We weren't really sure how those things would be developed, delivered, and assembled. And so Apollo Soyuz gave us a chance, jointly defined by us and the Russians, is my understanding, and developed an androgynous three-pedal interface. And so you go another, 15 years after that, there was some activity, knowing that we were headed towards utilizing a space shuttle to develop and assemble pieces of space station, knowing there would be future visiting vehicles. There were some efforts to develop a U.S.-based docking system. I believe that was done by Rockwell International and probably some other support contractors. But also at the same time, we were post tear down this wall kind of place environment, and so there was lots of strange things happening around the world. The Russians has also the Soviets seem to have collapsed, and there was a decision made at the highest level of bureaucrats on our part was we could just buy things from the Russians and try to keep their scientists and engineers busy instead of them going off to other places and other things. And so at that point, the decision was made to buy the Russian APAS system. And so we demonstrated that on shuttle when it went to Mir. So we had a series of missions for shuttle launched and delivered, went to the Mir
mm.
space station. And we modified it for that to meet our requirements, and then we learned from that experience, and then we modified it again to support the beginnings of space station. However, it's a big, heavy mechanical system, and so our internal thinking was we should really think about what the next generation system beyond that is, and that's where I kind of arrived. And so we were thinking about it in terms of still maintaining androgyny, which the APAS mechanism provided for shuttle, Mir shuttle station, but we wanted to get rid of the requirements for force and to bring things together. So shuttle dock the station with several thousand pounds worth of force. That has a
Mm.
real dramatic effect on the systems that are already there. And so there's some complexity associated with the timing and criticality of docking with another vehicle. So if you do things poorly, have a failure at the wrong time, it could be a very bad day, which has been demonstrated and happened in space a few times. At the same time, the force that you hit when you're going to strike a vehicle that's built very lightweight, very flexible, those forces are detriment to things like solar arrays and other systems that are on board. So our path was going down the path of how can we reduce the force requirements for docking. And so the earliest stuff that we did internally to NASA was for the X-38 program, which I mentioned. And so we were electromagnetic capture and some closed loop control, force feedback kind of stuff for alignment. And so that's where we spent really probably the next 5 to 6 years. That gets us to a relationship we had with ESA. And so the ESA actually was kind of a joint partner with us in the X-38 program. So a lot of the work that we did then evolved over time towards the development and the desire to develop an international standard, which you mentioned. It would be nice that folks who come to space from different countries would all meet the same standard. And so
Mm.
we had a separate system that used this closed loop control for alignment, for pre-alignment, for and then magnets for capture set of trip latches. But the decision was made again at the highest levels that we wanted to maintain this sort of connectivity and relationship with the Russians. We had already used the APAS system for shuttle station stuff, and so it was decided that our standard, our very first in-space docking standard, would match the Russian interface design, and so that took us out of. We have the NASA docking system now. It's Block 2 is in development. So we go back to sort of pre block one, pre even block zero. And so the influence of the standard, the desire to maintain that compatibility so that the Russians who were going to be a signature on the standard ultimately at the international level, we moved away from the force feedback, closed loop control. We moved away from magnets back towards the APAS interface. And so, which is what we have today. It's actually a good system. It does have some limitations in that some of the complexity in the latching systems from other places are good in low Earth orbit, which we would characterize as a relatively warm environment. But we've learned as we've gone through the NASA docking system Block 1 to Block 2 environment, the developments for environments, going into deeper space, it's colder. And so some of those systems were designed don't really work as well. And so that's why we're
Mm.
at a Block 2 development level today. So that's probably more than you asked for, but that's sort of a brief
It's
history
fine.
and time for docking. So,
I'll translate for the non-scientific community watches this. Wouldn't it be nice if everything would fit? Essentially, because it doesn't, and that's an issue. I do have a question, and I mean it in a positive way, actually, because I have this situation myself many times. When you think about what you did the last 30 years and what you do now and where it all started for you, do you sometimes have the situation that you think, how did this all happen? How did I get here? Like what's going on here?
oh yeah, there definitely are days I think, how did I get here? And I think it's a modern thing. It's like the what do they call it, imposter syndrome. It's like if people really knew
Yes,
me,
yes, yeah,
they would sort of think, how did this guy
yeah.
do all this stuff and get here? I just like many things, you sort of end up being lucky in the right place at the right time.
Yep.
You start out doing design work and analytical work for mechanisms, which I'm a mechanical engineer. That's what I was trained to do and designed to do. I was lucky to have an opportunity to sort of be what we call a cooperative education student back then. So I'm still in university. At the same time, every other semester, I would get the chance to go to work for NASA, sort of that dream job, and then ultimately get a chance to convert. So just time happens. You find some place that there's a need. You have a passion for sticking to it, and then ultimately, over time, you learn the discipline. It's not just me. They're literally in the area of docking systems. There are literally dozens and dozens of people that
Mm.
support all of the programs today. People like to think NASA of Apollo age is a single program. Well, Artemis is about 7 programs. And so there's a lot of vehicles, there's a lot of things that are happening. It takes a lot of people. And so it is nice that we have gotten to a place where at least at one place we have an interface defined, we have enabled interoperability, but still it's hard. It's not as easy as if you just meet the standard, because as we develop the standard, we're using it practically. We still find on regular things on a regular basis that are, oh, we discovered something that's a challenge. Different designs by different vendors in different countries. It's still a heck of a lot of work to
Mm.
ensure that
Yeah.
we're going to, when we bring things together in space, they actually come together and work.
And I think it's like with everything else in life as well. If it looks super clean and easy and nice, that usually requires the most work, basically, because it takes for, it's like with sports. Like, yeah, I can watch Michael Jordan and it looks very easy. Yeah, try doing that yourself, basically. And I think with on the technological part, it's like this as well, right? And I mention this specifically because, like, we have a lot of people watching, theoretically at least, and yeah, you're watching on your smartphones now, and like it's very easy to do that on an Apple, but how did we get here, right? And the same is with space, so appreciation is, I think, in order. And follow-up question on that: what did motivate you to actually become a mechanical engineer? Was it like those like Asimov novels that inspired you, but usually inspiration is not enough? Was it like Chris Hadfield? I talked to him and he mentioned it officially as well. Like, he designed his whole career because he wanted to be an astronaut from like a very, very early on age. So everything he did was specifically designed to have this job. And was it the same for you as well? Where you thought, yeah, okay, mechanical engineer, and then I got at least a shot at NASA, or what was your
Well, that's
goal?
interesting. Recognizing that probably if there's a million people, there's a million unique paths, right? That people have taken. I did not grow up, other than that one summer of 1975, where I probably ran around with my buddy saying we were going to be astronauts. At some point, that was never my goal. My long term goal. Um, but I've always seemed to maybe be sort of mechanically minded. I can see gears and levers and linkages way much better than I could ever see electricity stuff
Yeah,
or chemical stuff.
yeah.
And so I seem to have lapped onto. And I was fortunate for me because I grew up with a dad who worked on muscle cars, and so at some point in
Mm.
age I got to help, and so I sort of always liked the feedback of doing tactical things. You can figure out how something works, you can take it apart, you can put it back together. And so it seemed to me like an obvious fit. Um, Again, I was sort of lucky in the sense that always enjoyed science and math, STEMmy kind of stuff. But when it kind of came down to it, and I got past the first couple of years of college, which I started sort of more of in the physics kind of realm, I decided at some point, that sort of maybe a mechanical engineering degree was probably a path for me, and because I had been working on cars and trucks and things, and so I could see that you can see how things come together, how they come apart, how they work, and that's probably more of my motivation. And that just was lucky for me in the sense that my university that I landed at towards the end was University of Oklahoma. I had pretty much finished the basis of a degree in mathematics because I was always good at math. But at some point, I was like, I'm not sure what I'm going to do with just a math degree, and sort of re-enlisted is the way I kind of say it in terms of I think I should become an engineer. It was within that program of a second degree that I found out about the cooperative education opportunity with NASA Johnson Space Center and pursued that, and was fortunate from a timing perspective to be able to be picked up, which then translated into permanent hiring later. So no magical path, just always been lucky, in the sense that I was sort of in the right place at some of the right time, but having the skill set and being ready to offer as a kid in college, pursuing sort of some bigger picture dreams of working with my hands, and that's why I'm a mechanical engineer. And I think some of the reason that I was able to be the kind of person that NASA could try out, because that's what the education programs are about, is trying out youngsters and seeing if they're a good fit for the agency.
Obviously, I have to ask a follow-up question. What's your favorite car then?
It's the one that's sitting in my garage. It needs to be restored, but it's a 1966 Pontiac GTO.
All right.
Nice.
So it's still basically an ongoing hobby project for you. Like, do you do it like the whole, you fix it up completely, then you sell it and buy a new one and do it, or
No,
like
it's actually the first car. It's the first car that my dad ever helped me buy. Did a lot of work on it. I drove it a little bit in high school and college. I had to park it because it wasn't reliable. Go to college, get a job, get married, have kids. So now's the
yeah.
time to finish the job. So it's been something that's been sitting, gathering dust. But since basically my wife and I are empty nesters now, we're at a point where very likely in the next year or two, we'll have much more freedom and disposable income, and to the level of I'm going to bring Phoenix back to life
Hmm. Great.
right from the end.
I, I absolutely no skill set to do that. Um, but I absolutely like I build other things. In my family, for example, my uncle is building up old guitars, right? My father is building everything out of wood, starting from sheds and stuff, and I can build anything, electronic computer systems and stuff like this. So I understand how the satisfaction that comes with it when it's actually working in the end, basically. Actually working in the end. Alex,
Working. Nope, 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 nope. Not
you're the
working.
one working.
um, does the Pontiac drive at the moment? Is it drivable, or is it just standing on four bricks? Or what?
It is
How
it
can we
is
imagine
not drivable at the moment. So it used to be drivable, but again, at some point, the busyness of life, chasing kids, coaching teams,
this?
that kind of stuff, it just sits and gets pushed, and then stuff get piled on top of it, right? And so we're at the point in life where I hope to be able to dust off the dust and then package it, pull it forward, and then decide if I really want to, do a sort of a frame off restoration, or just make it a daily driver, those kinds of things. So, but looking forward to that phase. I just turned 58 not too long ago, so I got some time left, and I would like to finish something I started when I was 17. So.
What do you do in your free time? You mentioned the Pontiac, of course. I think you're putting a lot of hours into this project.
I actually
Repairing.
have not spent much time on that car in a long time.
Oh,
But I have another project that I do. I think it's probably actually related to the fact that I'm a mechanical engineer as well. I believe I can fix and remodel just about anything. And so, when my son Kate graduated college in 2020, we bought him a house on Galveston Island that was a 100-year-old house, or nearly a 100-year-old house. Had first generation cotton wiring called knob and tube. It had 100-year-old plumbing, and so I spend a lot of my free time restoring his
mm,
house. And so it is something I would like to get done, but taking a structure down to the wooden studs and putting it all back together, 100% wiring, 100% plumbing, doing the woodwork, doing kitchen work, doing plumbing work it's again, it's a hands-on thing, right? And so
yes.
um, it's just something that I
I,
do enjoy.
I, ju- I just like the thought that actually the guy responsible for the most high tech stuff in humankind in his free time is actually working on the lowest high tech stuff that's available. And so basically, you cover everything from 200 years ago up to tomorrow, basically,
In the
which is
future, I
which
hope
is
so.
yay, yes, well, the future comes faster and faster. I would say it somehow it speeds up. By the way, it speeds up. Does the whole AI thing and like quantum computing somehow affect your work? Like, because obviously it's a big trend and everybody in the private sector talks about it and everybody uses useless AI for some nonsense they could do themselves. So does it affect your work yet or not so much?
Not so much. I think there's obviously a tremendous amount of dialogue right now within the agency about the applicability, the efficacy, so to speak, of AI. Um, Probably in the near term, it will only be limited towards, the automation of documentation stuff. There's a significant amount of paperwork associated with spaceflight. If you think about going from the beginning of the design phase all the way through the development and eventually certification, and then the mission preparedness, and then the mission operations and that kind of stuff, there's a significant burden and overhead associated with just the logistics of tracking data. Materials and parts have to have full traceability. Data and analysis taken from either analytical work or from test work. There's a significant amount of I think there is some benefits associated with having AI be able to look at those kinds of things and take some of the burden off of engineers from a day to day perspective. However, I think we're not quite there in terms of trust yet. There's going to have to be a level of trust that's I think is built over time, and it starts small. So we do have some internal AI tools that are being rolled out, but they're not, I think, in a very applicable place yet in terms of making space flight uh, easier yet. I think human spaceflight is hard, and there's lots of things that happen at very critical times, and until you get systems that have been developed and used, and I would say for many, many years and many, many applications. We don't have 2001 Space Odyssey HAL yet. We're a long way from that, from having a system that sort of keeps an eye on everything. However, I think we will get there eventually, and I think we will have artificial intelligence at a level that does complement and support human spaceflight. I'm not so sure we won't have very much. We will have some of that probably sooner in the areas of medical science. We're going to send people into space for long periods of time, like a Mars mission. There's a lot of data that can't be contained in a couple of doctors' heads, and you can't rely on the with the time delays between communications potential. We're going to probably be able to utilize AI to help sort of put a doc in a box kind of thing, a doctor in a system to help aid. So you can sort of see the management of information, the huge breadth of information, the depth of information. That's where I see it helping first. I'm not so sure I'm convinced that AI helps us build a better rocket engine right now or build a better structure right now until I see it being used that way.
So Star Trek Voyager became true after all with the holographic doctor, basically. So do you see actually that's like happening Mars and or moon bases? Because everybody, like, obviously I'm asking your private opinion, not the official NASA opinion here. I have to clarify. Does
Yes, that's a good
James Lewis see
clarification.
that happening?
Yeah. So the Artemis program, and then I use that more as an umbrella descriptive program, like Apollo was a program. Artemis program does have its sights sets on a more sustainable phase on the surface of the moon. We're not there yet. We haven't even returned humans to the moon yet, which hopefully humans will fly around the moon early next year. Um, but yes, I think the idea that we should not go to the moon just like Apollo, which was I kind of always jokingly called it's a backpacking trip to the moon. We went, we stayed a couple of days, we came home. At some point, you run out of food, you run out of air, you run out of clean laundry, right? And so we're going to return to the moon sort of the same way, but has been commissioned a decade ago that we should transition pretty quickly into sustainable lunar presence. And that would rely on a lot of commercial participation. So it's not just NASA and NASA rockets or NASA prime contractor rockets and that kind of stuff. And so, yes, we do need to do that. And I would say, barring an Elon Musk Starship throw yourself in the cosmos kind of trip to Mars, we do need to validate the kind of systems and technology and capabilities and operations on a sustainable phase in the moon. I think before you can ever credibly say we're going to go to Mars, in my opinion. Again, as you said earlier, the caveat this is my opinion. So we will. I've been to NASA almost 34 years, and in 34 years, every year we've always been 20 years away from going to Mars, right? And so here today, 34 years later, we're still 20
It's
years away from going to Mars.
like fusion energy.
So, anyways, I don't know if I really answered your question. So, I think
You did.
technology wise, and this is something I've said for a while that I do believe is true. I don't think there's a single existing system, rocket, subsystem, component, ECLS, EVA suits, propulsive system, avionics, electronics. I don't think there's a single system today that credibly provides you the reliability and redundancy that'll take us to Mars and back safely. It doesn't exist today because we haven't needed it yet. Now, does that mean we can't develop it? I think so. I think probably structures and systems have to be half the weight, and I think reliability, if you think about it from a stochastic perspective, we're everything is 99.99 whatever reliable. Well, we need a couple of nines on the end yet. We've got to add a couple of
Mhm.
decimal places, I think, before anybody but pioneers jump in a covered wagon and send themselves. We want to bring people back safely. We've got to increase the reliability and robustness of space systems, and we got to take the mass out. And we're not there yet. Did we get there going to the moon and learn how to do that? I think so. But again, we're still at least 20 years away from Mars.
Can you
Yeah.
actually explain before Alex can ask another question? You mentioned it's significantly harder to go to Mars because it has to be more reliable. So how does that scale up for somebody who has no idea for math or engineering? Why is it significantly more difficult to go to Mars in terms of reliability?
Well, the fundamentals of it is once you depart to go to Mars, you're not coming back until you reach the place in space that you need to get to, which it would be if Mars is a destination to get there and then turn around and come back. And a lot of that is there's just a length of time. Even fast Mars missions, they're a couple of years, and the longer Mars mission round trip is multiple years beyond that. And so when you think about if you wanted to take a road trip across the United States from one coast to the next coast, the east to the west, and you said to yourself, well, this is going to be fun. I want to do this trouble free. I'm going to use my 20-year-old car, or much rather have a modern, brand new car. From a reliability perspective, it's much more likely that the older the system is, it was not designed, it's either aged or decayed to a point where it's not as reliable as it once was. When I use reliability, I mean the fact that you can trust that it's going to deliver its performance at a high enough level that you want to sort of bet your life on that kind of support. So for me, it's just simply put, if I'm going to take my family on a journey across the country and I want to do it safely and stay on time and it not cost me a fortune to fix along the way, then I want to use a higher reliability car. So that's sort of maybe a very rudimentary, simple analogy of when I say reliability and robustness means that I can drive through the mountains, I can drive through the desert, I can drive through the rain, I can drive through the snow, and I'm going to get there and withstand all of the environments along the way. I'm not going to break down, and so that sort of leads me to sort of probably the next thought is when we take that really one way trip. Not really one way trip. You have to be able to come back in terms of when things do wear out, when things do tend to break down, we're not going to have to be the ability to bring a spare for everything with us along the way, right? We don't have, lots of extra room for batteries or structural components or bolts or nuts. And so that's another facet of the reliability of things. They just have to be designed so that they don't break down along the way. And because we don't have the ability, we don't have Star Trek replicators. Maybe we can do some 3D printing. Maybe you take enough raw stock, but still, you can't take all the stuff that you need with you. And so we can sort of deal with that logistically. You can sort of say, I can guess what may break, what may wear out, and I can pre-place maybe assets. I can pre-place a cargo vehicle. I can pre-place something that's got some spares there. But even there's risk associated with that. It's got to be there. It's got to be the right thing that breaks, and you got to have enough of the right stuff, kind of stuff. So there's many facets of that, and that has nothing to do with how we keep people safe in space with the radiation environment in microgravity or zero gravity for a long period of time. But so hopefully that helps people understand what reliability means in the spaceflight business.
Yeah, I ask specifically because obviously 99% of the population only watches space movies and series, and there it's always very easy. So I think it's a lot of people just simply say, yeah, why don't they just do it? I mean, I saw it on TV tonight. Why can't we do that? Basically, just beam them there. Alex, you want to ask something?
Yeah, I'm always fascinated how people tend to forget what a harsh environment space is. There's no air. There's a lot of radiation. Um, Heat becomes a problem because you can't get rid of it because there's no air, no fluid cooling you. So this was shocking for me when I heard the lecture about satellite development and thermal development of satellites when I studied aeronautics. And the professor told us that heat is a problem. Well, everybody thinks space is so goddamn cold. No, yeah, maybe it is, but heat does not simply vanish. It's there, and you're producing it, and you have to get rid of it, and that's a really really big problem. Not talking about radiation and micro satellites or micro meteoroids and something like stuff like that. There are so many problems you can't imagine when you're sitting in this small layer of air surrounding our planet, which become really really big issues when you're in space. So just as an addition to why is it hard to get to Mars, even going to the moon is hard. The regolith on moon is not like sand on Earth, which is washed round and which is nice to sit in. This is really like glass shards, as far as I heard it. So moon is no nice environment too. The only nice environment we have in this solar system is Earth, and everything else is deadly for humans. There's no space in the solar system where we can exist except the biosphere of our planet.
Yep.
And this is a very, very small portion of the solar system.
I saw Professor Brian Cox actually in a podcast, I think 2 days ago, and he was asked what is the worst place for humans in the universe, and he actually literally said, well, everything outside of Earth is pretty crap.
On point, as always. So I had my rant. Another question regarding spaceflight missions and space missions. What's your favorite mission when it comes to uniqueness? What was the mission where you say, "Wow, this was awesome"? For me, for example, it was the Curiosity mission, the live stream of the motorized landing. This was awesome, in my opinion.
Yeah, I mean, you can probably, whether it's American missions or other countries' missions, there's been some pretty exciting things. Mine would probably be a little bit more personal, because we had the opportunity in the mid 2000s, 2006, 7, 8, 9. We were back as an activity under a major program. It was the earliest versions of what was called Orion today. It was called MPCV, the multi-purpose crew vehicle. And so we were, not quite yet past what their next generation docking system really would look like, what the standard was going to look like. Um, but there was a time where post Columbia, where we were not going to go back to Hubble, and so I'm getting to the mission that I want to reference is actually a shuttle mission that was the first and last mission to visit Hubble. Was STS 125, I believe, if I remember the number correctly. And so the people who did the Hubble management of Hubble as a telescope was out of Goddard, Greenville, Maryland, and they knew that shuttle was going to go. At this point, we knew the shuttle was going to end in this life expectancy of us program is going to go away. And so they came to us because we were the only people in the agency working on docking and said, hey, we would like to think about the modification of the Hubble aft bulkhead during the next and final human shuttle mission. When they went and did they do the upgrades of components and instruments and science instruments, and they do the servicing, as they call it. And so they came to us and said, we want to use what Orion's going to use. And we said, well, we don't have that because we're still developing it, but we can derive something from the information, from the technology that we have developed today. So that's what we end up doing in the span of really less than a year. We took where we were at with our current docking system interface definition design, and we extracted a very, very, very simple passive interface We designed it, developed, certified it. We delivered it to the Hubble folks. They integrated it into their servicing mission, and they actually delivered. And when the normal servicing of Hubble was shuttle visits. It reaches out with a robotic arm, it grapples, and then it bursts the HST into the shuttle payload bay into a specific assembly they call the FSS, the Flight Support System. And so what we were able to do for that last servicing mission is they modified that FSS. And so instead of when they finished the mission doing the normal unberthing grapple thing and send it away, we actually left some stuff attached. And so that hardware that's we call HST lids because the docking system worked from the earliest days was called the low impact docking system. So we called it lids for a very long time. So we actually were able to develop and certify, deliver, and then it was installed and left HST lids. And so you can find some actual photographs of the hardware that we developed. It was installed on the bottom of Hubble on the internet. And so I'm pretty proud of that. And so while it's not compatible with the current international docking system standard, we do have the capacity because we always have requirements at the agency at the international level that a vehicle needs to be managed to its fullest life. And at end of life, it either needs to be deorbited or it needs to be boosted into a higher orbit. And so we actually have provided the agency a way to return to Hubble, maybe in an automated fashion, not like a shuttle, not with crew, so they can rendezvous and dock, and then they can decide whether they need to push it into the ocean or whether they can safe it into a graveyard orbit. So I'm pretty proud of that. That's kind of special to me because if I think about and look back over the course of history of NASA, uh, uh, U.S. did not have any new docking hardware since Apollo Soyuz, and while we do have people flying with NASA docking system today, in 2009 we installed half of the docking system for use for later. So it was pretty exciting that we were able to be the group that helped enable a future rendezvous and docking in space, and the first one since 1975.
I would say we have about 5 to 10 more minutes.
Yeah,
Before we close it out, I always try to, let's say, inspire young people who might watch this, because I imagine a lot of people ask themselves, well, I'm like 15, 16, 17, 20 years old. How do they get to NASA? Like, if they show talent and if they have the motivation, like what am I supposed to do if I'm an 18-year-old kid graduating from school, let's say somewhere in the United States? Like, how do I approach this? Like, what should they do if they really want that?
Um, I love this question, and I've gotten it, believe it or not. I was fortunate a few years ago to be loaned to an organization called the International Space University, and they've been around since the mid to late '80s, and have a physical university in Strasbourg, France, right now. And I was loaned to them for effectively a year to be the program director for their space studies program, which allowed me for a year to really get engaged and involved with people from all around the world. Spent a couple of months in Australia, Adelaide, Australia, and almost 3 months in Sao Jose dos Campos, Brazil. And so I got that question a lot because there are people not just in the United States. I think there are people all around the world that are, especially the younger crowd, that are trying to figure out what space means to them. And so part of that might be, how do you get to NASA? And so it's much easier if you're an American citizen or a naturalized citizen. Let me just tell you that right now, because that seems to be you're talking to people who are in school or postgraduates from around the world. They say, I want to work for NASA. And I say, well, then you got to get to the United States and you got to become a citizen, or you got to work for one of our international partner contractors. Because I consider them part of the NASA family. We work with ESA, JAXA, Canada. On Space Station, we still work with Russia. I work with Russia regularly because we have the International Docking System standard. But if the question is how to work for NASA, how to come to one of the 10 centers, you got to get prepared. You need to have a STEM education. Um, you have to have more if you want to be an astronaut, right? You need to be, advanced degrees. You have to have credentials in things like flying planes or or deep sea diving, that kind of stuff that demonstrates you have the kind of mind that can handle tasks in dangerous, critical situations. But if you want if you want to come and you want to be involved, um, probably the little side thing I'll add is, for every person that goes in space, there's probably tens of thousands of people that are engineers, that are scientists, that are involved in making that mission and the hardware and the systems work. So I take a lot of pride. I would love to have been an astronaut, but it didn't happen for me. But I take a lot of pride in the fact that I'm contributing to what can happen for other people, those special people. And not everybody can be an NBA basketball player or Major League Baseball player, but we can contribute to the activities. And so one of the things that I tell people that were at the younger end of the spectrum is when you're growing up, you need to read everything you get your hands on. Maybe that's a little different now that we have so much access to the internet technology, that kind of stuff. But for me, the internet didn't exist, and so like we talked about the kind of books that I read when I was a kid. For me, it was always science fiction. It always sort of suggested the hope for the future of exciting things. So I tell everybody, consume information, whether that's a book, my preferred method, but read, expands your brain. You can read about things that you can't experience every day. So so open up your brain by reading, learn new words, learn all the kinds of things. But you're going to have to get an education. You're going to have to get the right education if you want to work in a technical field. Now, that doesn't mean we don't use business people and HR people and medical. There's sort of so there is a desire. If you want to build hardware, you want to develop systems, you want to be an engineer, you want to be a scientist, then you've got to prepare yourself. You need to make decent grades. You don't have to make perfect grades in high school, but you need to make good enough grades to get to a place where you can get, at least a college degree. And so you need to be primarily, we use more STEM career people, science, technology, engineering, and math. And so there's a lot of flavors of that. And so I would encourage people, don't think math is hard. Go figure out why math is hard for you and go figure out how to make math easier for you. Repetition is the key to everything. So developing the skills in most of the engineering things, even on the biological side, you need to be able to think about, how math works and how science works and how technology. And so there's a foundation there. So you need to be prepared to get, the right kind of degree to get whatever field, that you need to be, and you need to be in the right place. It's easier, like I said earlier, in the United States. I think if you want to work for in the space business these days, it's incredible. How much work is being within the commercial space. It's amazing to me because we have a challenge that we've never had at NASA before. Is we're losing critical capabilities to commercial space people because they're doing exciting things too. You think about SpaceX, and you think about Blue Origin, and you think about Axiom Space and Intuitive Machines. We're sending landers to the
Mhm.
moon. Private companies.
Yeah.
You have a private company building the next generation EVA spacesuit. So there are plenty of job opportunities that aren't directly with NASA. And I would encourage people, and I tell people, go look and see because those industries are growing so fast. There is a constant need for people. So there is opportunity. Outside the United States, it gets a little harder, I guess, because they don't spend the kind of budgets, they haven't invested the kind of money in the space business. But that's the question I got from interacting with people from 40 or 50 countries in that one year was they want to know how to get involved, how they and so I think there's opportunity. I think the internet can take you and show you lots of places that you can work and contribute, but many times it's wherever you're at starting something on your own. And I saw many and met many young people who called themselves analog astronauts because they have this dream of vision of being a future astronaut, but that's reserved now for a select few in NASA missions, Chinese missions or Russian missions, right? Or billionaires, right, who get to take a day trip into space. But I think the future is evolving and changing pretty fast. But it begins with education. I think it begins with STEM education primarily. That doesn't mean we don't need other business support functions, but and you can do that. They're just as critical to a program. The budget guy is just as critical to a NASA program as some of the scientists and mechanical engineers and such are, because they got to make sure that all of the pieces come together to make an activity happen.
All right. Thank you
Sorry,
very
I'm
much,
a, I'm
Jay.
a little
No,
long-winded there, but
it's no problem. In the end, it will sound very much to the point, and I
yeah,
think the message is that's what counts
yeah.
actually, because I always try to inspire people, because I think a lot of people think, oh, it's too hard and I'm
No,
not good at math, and oh, they would never take somebody like me. And I always want to show them, no, if you really want, they'll take you. Like you can find a way, and whatever it is you want to do, if you want to be a professional sports person, you can give it a shot. At least try it, basically. And somewhere along the way, maybe you find something else, but don't tell yourself they won't take you, right? So that's
nope,
a
you should
message.
not. And your comment made me think of one other thing. Uh, because the industry is growing quite large, there is a whole secondary layer of capabilities for people who are good with their hands. If you're what we call a technician kind of mindset, people who actually can get in the lab. They're not always engineers. They don't need to be engineers. They just need to be able to follow instructions. They have to have skills, whether it's laying up composites for some kind of composite tank or putting together assembly printed circuit boards or some kind of mechanical assembly. There is a growing need for people who have the ability and the desire. Hey, I don't want to go to college if I still want to work in space. There's a lot of jobs for people who are hands-on people. A lot of hardware, all that hardware has to get assembled and tested and checked out by somebody. And there are plenty of jobs I think there, and that's growing as well.
All right. Then, Alex, unless you want to add something, I would sum up the
No,
cast.
no, I don't want to add something.
Then,
Well, just one thing. In fact, you just have to be brave enough to start and stubborn enough to stop.
yeah, exactly. Like, look at me. I cut this out of the cast, obviously, but look at me. I'm really bad at math. I have rough ideas, and I published a scientific paper on the unified field theory just because I could. Basically, right? I'm not saying I'm right or I have like in-depth knowledge, but just get out there and do it. What's the worst case scenario, right? Like, people tell you you're wrong and then you just continue on, and then basically there is no clap back and people tell you you're stupid or something like this. Just go out there and try it, just for the fun of it. And if you try enough, you succeed at some point, basically. So I'll close the cast. And first of all, again, I want to thank our fantastic guest, James. Thank you so much for being here. Thank you so much for investing your valuable time to talk to us. Thank you for being here, Alex, as always. And lastly, I always give the guests an opportunity for one last statement. Anything you want to say to the audience, or add or plug your newest book, or maybe a sales ad for your car or something like this, James?
I would like to thank you two for inviting me to the podcast. This is my first podcast, so it's been a great experience. Jern, it was nice to connect with you recently, and it like I said earlier, it's been a real pleasure for me to really meet people from all around the world. In fact, one of these days when I do retire, I really hope that I have the opportunity to focus in the area of what I call international external relations in the things of space. And so it's exciting to find people in other places that have hopefully my passion for what I have been doing comes through. It's visible, I think. But it's interesting and fun to find people from around the world who are looking and saying, hey, space is an exciting frontier. And it's not just a Star Trek thing, right? It's not a Star Trek phrase, right? It is reality of life is everybody's future on this planet, the only planet we live on, which we talked about earlier, will benefit from the business of space. We are going to discover new things. We're going to create solutions for how to keep people alive, how to make people productive in space. All of that translates back to Earth and terrestrial life. And so we do sort of hear that question many, many times. Why are we spending all this money on space? Well, all you got to do is look at the history of space so far. We've solved a lot of problems, whether it's medical technology, whether it's some kind of new material or new biological thing that was done in space. It's very important that one of the things that I kind of sort of agree with Elon Musk is we ought to become not just a single planet kind of species, because it doesn't take much to realize there's a lot of things out there in the universe that are very dangerous, and it just takes one rogue asteroid. And so, if as a species we want to continue on, even though we're not talking about probably in my lifetime, but we've got to make that plan and set that path towards developing the capability to live off planet and thrive. It's not just it not just means go to the moon and backpack it kind of thing, but it takes a lot of people, and I believe from my experiences from meeting people from around the world is we need people from all nations, from all backgrounds, from all industries, all sectors, because there are genius people everywhere. They have great ideas, they have great capabilities, and so probably the last thing I would say before I say thanks and goodbye is I sort of have viewed for a decade that if we really want to go to Mars, we've got 10,000 really hard things to solve, really challenging problems. It's 10,000 is just a number, right? NASA can fund and solve two at a time or three a year or something like that. So we need a lot of people to get on board with us and to start really thinking about how we solve some of these problems, because it would be nice in my lifetime to think, hey, we did something and we saw some people land on the moon that we expect them to be able to live, expect them to be able to come home. So anyways, that's kind of my last kind of thing. And I do again appreciate the time, appreciate the hospitality, and looking forward to keeping an eye on you guys and see what you come up with next.
Yes. Alex, you want to add something?
No, I don't want to add something.
All right.
Thanks a lot, James. What was really a pleasure.
My pleasure.